Hello, I'm Kim Loughran. In the next few minutes, I'd like to share with you some of our insights about mixing. Good mixing results depend on several different factors. In this video, we'll show you some of them. But instead of depending on words, we'd like to show you some sequences using scale models. We hope this will increase your understanding of mixing and of the several factors behind good mixing results.
In most mixing applications, there must be varying degrees of both turbulence and bulk flow. The term bulk flow means that the fluid in the entire tank volume is in motion. In many mixing applications, there's abundant turbulence in the vicinity of the mixer, but the overall mixing result is controlled by the strength of the bulk flow in the entire tank volume. In such bulk flow control applications, the submersible mixer has its particular advantages. It's the jet from a submersible mixer that creates a bulk flow in the tank. Thanks to its freedom of placement and orientation, a submersible mixer can create a good bulk flow that reaches all parts of the tank. But it's not only the placement and orientation that are important to bulk flow creation. Selecting the right mixer capacity is also essential to ensuring the desired bulk flow velocity. We'll look at two major parameters: mixer power consumption, which is the price one has to pay for the final mixing result, and mixer thrust, which is equal to the reaction force from the jet that actually generates the bulk flow. All in all, what we want is a mixer thrust to create a bulk flow, and we want to achieve this with a minimum of power consumption. We put together a model so that we could demonstrate how power, thrust, and resultant bulk velocity relate both to each other and to the mixing that takes place. The model shown here is an annular tank with an overall diameter of approximately 1.5 meters. The model mixer consists of a scale propeller driven by a right-angle gear unit. To visualize the flow patterns in the tank, and particularly to demonstrate them on film, we used water-filled ping-pong balls. For this series of demonstrations, we selected two propellers that look very similar. In the examples that follow, both propellers are mounted and oriented in the same manner. In this split-screen view of the model, both mixers are running at an input power of 8 watts. Note how the ping-pong balls are carried along at a much faster rate in the right screen. This is despite the fact that both machines are running at the same power input. Here's the same test again. But this time, the power inputs are not equal. The test has been set up so that both propellers produce the same thrust. And now, as can be seen from the speed of the ping-pong balls in both cases, the bulk velocities are equal. Ping-pong balls may seem far removed from real applications, so we replaced them with solid plastic particles having a density higher than water. Again, it's important to note that power input to the mixer is equal in both of these examples, 8 watts. Note the difference in bulk flow velocity and degree of suspension. A side view of the mixers in action makes it easier to see how two machines with equal power inputs can have such dramatically different effects. Movement around the pour propeller shows a lot of energy going into the surrounding water. There's even some good scouring occurring immediately in front of the propeller. But a dune of settled particles is building up not far downstream. Now, notice the difference in the right picture. The energy from this jet is translated into a bulk flow throughout the tank, rather than just in the vicinity of the propeller. And the particles are well suspended by the bulk flow. What will happen if we again run the two model mixers at equal thrust instead of equal power? Here, both mixers are producing equal amounts of thrust. See how the bulk flows and levels of suspension are the same in each model.
You've now seen a few examples of mixing where bulk flow throughout a tank is accomplished by means of the mixer jet. You've also seen that mere power consumption doesn't really indicate much about mixer capacity. It's the mixer thrust that most directly affects the bulk flow and hence the mixing result. We hope that these demonstrations have given you some insights into mixing technology that'll be useful in your future work. Goodbye and good mixing.